There's a company in Switzerland that you take a biopsy of cells and they can grow a full thickness graft of your own skin, fly it back here and install it. So that's, I saw the boy, he wasn't conscious, who was receiving the first trial of that product, that was very cool.
Hi, I'm Tamara, and this is TELUS Talks with Tamara Taggart. There's a team in Boston using cod skin to save burn survivors, real fish skin, and it works. Science writer Mary Roach joins us to explore our centuries-long obsession with repairing, replacing, and upgrading ourselves. Mary shares what she learned inside operating rooms and research labs where the line between human and machine gets blurrier every year. I hope you enjoy the conversation. Hi, Mary. It's so good to see you.
It's so good to see you, Tamara.
Yay. So your new book is called Replaceable You, Adventures in Human Anatomy. This is, I tell you, this book has opened up all kinds of questions for me. I had no idea more than half of this stuff even existed. You write about human anatomy, and how replaceable we can be. And I'm curious as to why, this topic showed up on your radar.
Oh, I think it's just part of it has to do with how old I am. I'm in my 60s now, and everything starts to wear out, and you start to think about, what could I pop out and replace if it starts to slow down, starts to get hinky.
So you have this idea, you're going to write this book, and then where was your entry point in your research?
Well, I tend to go places for each chapter. I like to have a scene and a setting and people talking and things happening. So it often has to do with what's happening when and where. So I go, as soon as I can go somewhere, I go. So I think one of the first places I went may have been, it was a conference of the Amputee Coalition. And I went with this woman who I met accidentally. She was a reader who wrote to me with a suggestion for a book idea, which didn't work out. It was about professional football referees, which I'm not terribly interested in. But it turns out she's an amputee, specifically an elective amputee, and I'd never heard of that. This is somebody who their foot was healthy but twisted, and she couldn't walk well on it. She's like, I want to take it off, and I want a prosthetic. And it took her years to find a surgeon willing to amputate her foot. And so she said, well, if you're interested, why don't you come with me to the conference? So it was this hotel it was in Desert Springs, I forget. Anyway, it was it's a big hotel that normally has businessmen playing golf, and you show up and they're like 50 people with prosthetic legs walking around the lobby. So it was fascinating just talking to her and talking to some of the people there about how do you make that decision. And anyway, so that was the entry point, just because it happened to be happening when I started the book. So I don't go in order of the chapters. I go when an opportunity presents itself, then I go. So, yeah.
But we've been doing this for centuries as humans, haven't we? We have been trying to fix and upgrade our bits and bots, our parts, our body parts for a long time.
Yeah. I mean, if you even just thinking about plastic surgery, reconstructive surgery, that goes back 1500 BC, people were crafting replacement noses because nasal mutilation was a form of punishment that was used throughout history. Like to hack off someone's nose was not only a punishment, but it was a deterrent. The whole population would see this person's face and know, oh, if I don't keep in line, they're going to lop off my nose. And it was this horrible kind of humiliating thing to do. So very early on, there was this procedure where you'd cut a flap in the cheek or the forehead, keep it attached at one point and twist it, flop it down onto the nose. And it would maintain a blood supply where you kept it attached, and you could create the nose that way. And then eventually disconnect it in the little, where it was connected. And that is still occasionally done today, that procedure where you take a flap of the forehead and use it to rebuild the nose. But you think about it, that was 1500 BCE. That was a long time ago. So this kind of thing, there's been a need for it for centuries. kind of amazing. Surgeons knew, you had to have the blood supply, and they had to leave it in place. And then later there's this Italian surgeon figured out, you know what, and rather than messing with the face, why don't we take a patch of the underneath of the upper arm, because nobody's going to see it. There's no hair there. You could, but that meant that you had to keep your arm held high over your head, kind of like you're checking for BO, like your head's sort of turned and it's connected to the upper part of your arm. And there was this harness to hold your hand there. So people would have to go around for a few weeks while while the flap of skin grew in on the nose.
Can you imagine where we'll be in 50 years from now, 100 years from now? Like, where will we be?
Well, I think certain things are really advancing surprisingly quickly. Bioprinting is one area. It's really tricky to do because you have to, you think about you're printing with cells. So and those cells are going to have to be kept alive. First, you're going to need to feed them. So are you printing the blood supply, or will the body grow those capillaries? You have to think about, if you're printing muscle, the way you align those cells, how the printer aligns those cells has to match what that muscle is going to do. If it's heart muscle, you want to print it in sort of a helix shape, because it's going to twist. The heart twists as it pumps. It's like wringing out a shirt, kind of. It's like that's how to get the most volume of blood out and pumped. So you've got to print the cells in a specific way, which is just, I just, before I went to this lab, I just pictured sort of, like my printer upstairs. You kind of just like push a button and it.
I was just going to ask you, what kind of printer is this? Can we get it at the hardware store or whatever? It's like a 3D printer, right?
It's a 3D printer. And this guy teaches, this is at Carnegie Mellon, the Feinberg lab. He teaches this course where you could take a 3D printer, and just the kind that you would buy at Office Max. You could take it and rejigger it, and you could actually use that. It's a printer that's switching between extruder heads. So you've got cellular material and then extracellular material, kind of like you'd have a 4-color brochure with different heads with a different ink.
Except it's for a major body part.
Except that you're printing like the ventricle of a heart or something like that.
Wow. Oh my, do you think that in the future we could get to a place where it's just no problem to replace anything?
Eventually, but it's so tricky because, well, there's two things that we are always going to have to worry about. One is infection is always a tricky thing whenever you're introducing, say some sort of titanium joint or some non-human material into the body. You also have infection to worry about, and also rejection when you're taking something from a pig or another human. You're going to have to suppress the immune system. So that's been a real challenge. 10 years ago, there was a lot of press about face transplants, arm transplants. There was a leg transplant somewhere in Europe. This was all going on, and it seemed like we were going to get really good at that. And you could just pop on take a part from another person and just stick it on there, good to go. But there's been a lot of issues. Again, the human immune system is just very reluctant to accept material that isn't part of itself. And so there are people now waiting for a second face transplant because their body's starting to reject the first one. There's people having a hand removed, because they're starting to have issues with it. So it's always you're always going to be dealing with that. But of course, AI is going to help a lot. There's a lot of work being done now where you can take somebody's blood, say, and you can regress it to this state called pluripotency, where you can basically instruct those cells to become what you need. Like you could take somebody's blood, regress it to pluripotent stem cells, and then instruct those cells to become, say, the neurons that produce dopamine for a Parkinson's patient, that kind of thing. But at this point, it's very, very expensive. It's kind of a bespoke process, patient by patient. So if they could create pluripotent stem cells that the body didn't have a response to, so someone else's, you could just get them off the shelf. And rather than taking somebody's blood cells or skin cells, regressing them, I mean, that whole process is time consuming and very expensive. It is amazing that it can be done.
It is pretty incredible that it can be done. And in your book, you do, you talk about all these breakthroughs, right? That we've had bioprinting and regenerative medicine and lab grown organs. So all this stuff you're talking about. But I mean, at the end of the day, it has to be through trial and error, right? Because you come up with the science, you make it happen, but then it has to go into a human being, and that's, I guess, where the trial and error is?
Also, keep in mind, whenever you manipulate human cells, um, now you actually have to get that that becomes something that has to get FDA approval. So now you're talking about clinical trials, and clinical trials, I mean, there's the preclinical, which is the animal stuff, but even just the human trials, that's, 10 to 15 years and $100 million. It's so that's slow going and it's very expensive. So it's a lot of things sort of start up and then stop because it's tough. I mean, I spent some time at this place, Stemson Therapeutics, they were doing really cool stuff trying to grow follicles so that you could actually have this crop of follicles that would be growing hair that you could then implant. Because with a traditional hair transplant, you start to run out of hair on the sides and back. So in this way, you'd have this unlimited supply of hair. But it was so tricky. They got it to the point where they were growing these two types of cells that you need, and the cells were coming together and they were producing hair material. Unfortunately, it wasn't growing up out of the skin. It was They called it disorganized hair. This is kind of like this black stuff under the skin. It's like there's the hair, but we got to figure out how to get it to grow up out of the skin. And so that was another round of experimenting and creating little tubes for this hair to grow up. And it, in the end, they didn't get enough funding on the next round of funding, and they closed. So I mean, so much work, and it was such cool stuff. So many people working, dedicating long hours to it, and in the end, just couldn't make a go of it. So it's tough.
It is tough, and it's what about, I mean, where does it end, I guess, right? Like, at what point do we go, "Oh, yeah, okay, so we don't need to go there." Like, do you know what I mean? Like, at what point do we go, "We really don't need to replace all the things on a human body. It doesn't all need to be engineered." Like, do you know what I mean? Like, is there a line?
Well, I think it depends on if you're talking about cosmetics or something that's going to save a life. I think some of the work that's being done with xenotransplantation, which is genetically engineering a pig such that its organs don't have this protein which alerts the human immune system in the same way that it would if you just took an organ straight out of a ordinary pig that had not been gene edited and put it into a human. There's this crazy, like, instant rejection that happens. So they can edit the pig such that that reaction doesn't happen. So now, they're getting closer to the point where that can stand in for a human organ, and that would be not the pigs would not be happy, but you'd be saving yeah, you'd be saving a lot of lives, so that's moving along, and, that would be terrific, especially, I went to China for that chapter partly because there's such a need in China because there's no cultural tradition of organ donation. It's not something people think of doing. It's not, that it has to do with, this belief that if you mess with your organs, you are disrespecting your ancestors, the people who gave you those organs. So it's just not done there. It's a huge population and very few organ donors. So if you could take, organs from pigs, and they actually were a lasting solution. Right now, about 9 months is as long as it's worked. So, not there yet.
So, one of the things we like to do here is asked our guests to choose a registered Canadian charity. You chose the TELUS Friendly Future Foundation, and we are going to make a donation as a thank you for you being here. So thank you very much for choosing them. And as we're the emotions, right? So there's the ethics, there's the emotions, there's the, because again, we're talking about people. We're talking about human beings. We're talking about, every replacement part comes with the story of another human being going to another human being. And so when you bring that part into it, I mean, we'd do anything to keep somebody alive, right? And we forget sometimes it's easy to just go down the path of science, science, science. And it's like, oh, wait a minute, humans, emotions, feelings. What about human resilience and the people that are needing these parts and the people that are needing these organs? What did you understand? I know you went into burn units, right? And that's, I mean, that's incredible, the work that they do in burn units.
I spent some time at the Mass General, that's in Massachusetts, the Mass General Hospital's Sumner Redstone burn unit, which is one of the best. And I met this woman who'd she'd been burned on 90% of her body. A serious third-degree burns on that much. It's a miracle she survived, but it is, and she was getting married soon and had invited her surgeon. She and the surgeon were very close because she's had literally dozens of procedures, especially because of a third-degree burn, the way the body tries to heal. The skin doesn't grow from down below where the regenerative cells are because they've been destroyed. So the body tries to heal by pulling together like a pair of drawstring pants. And then that this pulling creates this disfigurement where, say the line of the jaw is pulled down to the collarbone or an eyelid is pulled open. And so you have to release those, which creates a gap. And then you need to take skin from somewhere else on the person's body. And they may not have any space you may be talking about the bottom of the foot or the scrotum. What's left to work with? So it is slow going and just emotionally horrible. She talked about the first time she looked in a mirror. They try to cover the mirrors, but the place she went for physical therapy, they had not, and she wasn't ready to see that. And just that, the emotion of that and yeah, the kind of resilience it takes. I mean, she's an amazing woman. She's like, we went to dinner and it was a hot day. She's wearing a sleeveless shirt. And here I am, because I'm in my 60s now, like the way my arms look. I'm like, I don't wear sleeveless shirts. And she's wearing a sleeveless shirt and she's beautiful. I mean, it's a testament to her plastic surgeon that she looked as good as she did. I mean, but she had been through rehab for addiction. And she took a lot of the tenets of the 12-step program to heart, and that really helped her. But I was amazed just to learn what she'd been through, the number of procedures and the things that happen along the way
And it's incredibly painful painful emotionally, physically, mentally, all of it.
Yeah, exactly. I mean, there are some really cool things that are now available. You can take a biopsy of someone's skin, send it off-site, and they can grow out a very thin layer that can then be put in place on the wound, which helps speed the healing. Because you can use cadaver skin or cod skin or pig skin, and that is great. Is it sort of bio-dressing, but it doesn't become the person's skin. The body will eventually reject it, and it'll slough off, or they pull it off. So it's ultimately you're going to have to use your own skin, but now you can there's a company in Switzerland that you take a biopsy of cells and they can grow a full thickness graft of your own skin, fly it back here and install it. So that's I saw the boy, he wasn't conscious, who was receiving the first trial of that product, that was very cool.
Yeah. I found it fascinating that they use fish membranes. I would it would never cross my mind that you could use fish skin on people.
Again, it's just a biodressing. It doesn't become historically, they used frogs. They used puppies and kittens because they thought, "Oh, you want it to be young and youthful and full of growth potential." So they were like puppies, kittens, frogs, chickens. They're all of it people were using. And it all works as a temporary kind of dressing. But when it comes to something that will remain in place and become your skin, you you want your own something either grown from your cells or removed from another part of your body.
When you think about the bright side of things, when you think about, because we've talked a lot here, and everything we've talked about has an emotional side to it and an ethical side to it. That goes without saying. And we're never going to cover your entire book in, a 30-minute conversation. That's why people can read your book, Replaceable You. But when you look at the bright side of your work and the bright side of your book or what you found out, what is the bright side of things for you?
I think, I spent a good amount of time in labs with researchers, with scientists, and just it was refreshing and hopeful just to see the dedication and passion that these folks had, specifically in this era. I mean, here in the United States, as this book was going to press, it was about 9 months out from when the book appeared. That's when those big cuts, the Department of Government Efficiency, that's the Doge cuts began happening to labs. And just that was so sad for me to see all these young people and people in labs who were finishing PhDs and they were excited about their work. And so talk about resilience, for them to, just keep pushing ahead and remaining hopeful. That I just wish them all the best, because it's been a tough time, but just the passion. And I remember speaking to this woman. She was working in that bioprinting lab, and she described, I tried this, and the heart cells, they weren't pumping, they weren't doing their thing. And I said, it must be so frustrating and depressing when you've spent all this time and it's a failure. And she looked at me like I was crazy. She said, it's not a failure. We learn from every step. So now we know that doesn't work and we move forward in a different direction. And she just the fact that you're dealing with what I perceived as failure, but she saw it as just part of the process toward success and toward doing something that will one day make life better for people.
Yeah, that's incredible. I love that. Mary, I love this. Your book is called Replaceable You, Adventures in Human Anatomy, available wherever you find your favorite books. You can also find Mary on her website, which is maryroach.net, and she's on Instagram at author Mary Roach. Mary, thank you so much. It was a great conversation.
Oh, I really appreciate it. It was fun.
Thanks for listening to another episode of TELUS Talks with Tamara Taggart. Be sure to subscribe so you can join us every Tuesday for another conversation. You can also check out our website, telus.com/podcast, and subscribe to our YouTube channel at TELUS Talks.